what we're going to talk about today is how the server looks into the database and tries to compute lifts. Since this is a distributed protocol, each server really participates only in a little segment of a lift. And so they only have a little picture, they only have kind of their own little picture of the network. We're going to be using the simulator as a data set, and I want to show you just some of the built-in queries and some of the built-in views. And then when we get to the end, we'll probably clear this data set out and use the simulator to create another data set. So I don't know if you have any questions about that or directions before I get started. If so, just pipe in. So what we're looking at right now is this is the regular admin interface, and I've got 4 tabs open. So when I ran the simulator last, I configured it to have 4 instances of the server. So that's 4 MyCHIPs sites that is roughly equivalent to a service provider. And then I configured it to have 6 users per site. So, and then we ran the simulator to create a bunch of chits and tallies and so forth. And so there's an actual data set that's in here. Now, this is called SPA0, which is the first site, and then SPA1, SPA2, and SPA3. And then there's this sort of not that great optimized, but if we kind of refresh this, it sort of rearranges these in a little bit more optimal way so we can see what's going on.
You said there are different sites. Do those represent different servers? I'm sorry if you mentioned that.
Yeah, so a site is roughly equivalent to a database. And a database can have multiple servers and multiple agents around it. We're configured right now with 1 agent per site, and we have 4 different sites. So by database, we mean that these 6 users are all in a single database. If you look here, there's a tally right here connecting these 2 users. Valine and Franklin are connected locally by a tally, but Franklin is also connected out here to Joseph Mullet, which is on a different site. So, I mean, really, this is the kind of question I'm looking for right now. I want to make sure you totally understand what we're looking at. Does this make sense to you?
Make sure that so the square boxes or rounded rectangle boxes, those are foreign agents, right? They're entities that are on a site that is not here, this database, right?
Correct. Now we can see...
And then all the connections with the graph's internal, that's internal to the database.
Correct. So we can see agent 2. So if I go over to agent 2, I should be able to find Joseph Mullet. So let's see, he's right there.
Nice.
And we should be able to see him connected back to Franklin somehow. These are a little bit dense.
There. But because it was blue on the one, it should be red on the other, right?
Correct. And we see 2.073 on this link with Franklin. So if we go back to this other data set, we should be able to find the same 2.073.
So the sum of all chips in the whole system should be 0, right?
Correct.
Okay.
And I think that's probably true. Well, I think it's across the whole system. If we kind of simulate both halves of the tally, we should see that same 0 in a single database. So in our database, we have 2 halves of this tally. We have both the stock and the foil for this tally. For this tally, we're really only holding the foil. And for this tally, we're really only holding the stock.
Okay.
And I'm making the assumptions that blue are stocks. That may not be a valid assumption, but at least we know that we have positive chips. We have positive number of chips here on this tally.
So can you tell me the difference between the light blue and the dark blue?
Yeah, so these visual balance sheets just create a different shade of blue for all the assets and a different shade of red for all the liabilities. And
Okay, so it's a gradient, so that if you owe more, it becomes darker, or if you're owed more, it becomes darker.
Well, by chance, what we're doing is we're starting over here at 0 on the graph, and we're starting with the biggest tallies first, and then moving around to the smaller assets. And then we're doing the same thing, starting with the biggest liabilities and moving around the underside to the smaller liabilities. And then we start with the dark blue and start with dark red, and we move over here to the light. So the lighter would just imply that it's maybe a smaller amount than a darker
Yeah, but
amount.
it's not a relative, like how dark it is doesn't tell you how much it is. It's just the largest value is darkest,
Yep.
and the smallest value is
Yep.
lightest.
And then this inner circle is just chip assets in aggregate and liabilities in aggregate. So you can see that this line kind of corresponds to that line across there, but we can see that we have a total of 11 positive chips and a total of 8 negative chips. And then the inner square is the net value, and you can see that it's kind of blue-ish here and it's kind of reddish here, and it will turn darker red or darker blue based on the, how weighted you are in assets or liabilities. And if you're
These are all pretty close to 0 though, so they're all pretty white.
Yeah, they're all fairly white, but you can see this one is a little more red and this one's a little more blue.
It's pretty subtle.
So, I mean, this is meant to be kind of a game theory thing that people could look at and say, hey, I'm in the blue or I'm in the red. And eventually it'd be nice to add other fixed assets to this so that they could actually see more than just their chip assets and liabilities. They could see their whole financial well-being in a snapshot.
And then here's a question, like, why is, Joseph Mullet and John Rosa on the same circle? Like, does that matter? Or what does that mean?
The name again was Joseph Mullet and who?
The one right next to it, John Rosa, they're pointing to the same circle. What does that
Okay,
represent?
so these are two foreign users. Joseph Mullet is on agent 2 and John Rosa is on agent 3. And they both share a tally with Franklin.
So that means that both of them owe Franklin money. That's why they're together.
Correct.
Okay.
And then
Or
this
check.
kind of tries to group these in a decent way so we can see the relationships and hopefully not too confusing of a way. And whenever I run the simulator, it tends to look like this, where there are a few local connections and most of the connections are foreign connections. And I think that's probably the way it's going to be, unless you get on a really big mega site where everything is local. And when we do it on MyCHIPs.net right now, there are no foreign agents or foreign users, and so we just have a bunch of these round balls, and they're all kind of clumped together in the middle. It's very hard to look at. But when we're looking at a distributed network, it tends to look kind of like this. Now, if we add a lot more users, it gets confusing in a hurry. But for the simulator, I've been concentrating on relatively small data sets. And each of you should be able to run this simulator on your own, and we'll show that later on in the presentation. Okay, does that make sense so far? So I am in a folder that is test/sim, and we're just going to run some commands in here. And I've got a couple of shell windows open. And the first thing that I want to do is show that there is a script called report in here. And it's going to make it a lot easier so I don't have to type in a bunch of SQL commands. And the first one that I'm going to do is to query the tallies. And what we're doing is it spits out the command up here so that we can kind of see what the command was that was being typed, that's being executed inside this inside this report shell script. And so it's running the command symdoc, and symdoc is just a command. It's a shell script that's in the simulator folder. And so we run symdoc, we execute Q as the command, which means I'm going to run a query. I'm going to execute it on 0, which is the 0th or the first site in the simulation environment. And then I just type an SQL query. And I'm selecting a bunch of fields from MyCHIPs tallies v, which is the standard tallies view, and then we're going to order them by the tally UUID, which is this one.
Right.
And so we're trying to create a graph network, and so I want you to understand at the first level we're just looking at the tally table, which really represents the edges here in this network, or these tallies, and we can find those. So we should be able to find the holder is Ray and the partner is Dorothy. So let's just see if we can. So here's Ray and here's Dorothy, and so that's the one that we're looking at, and it has 4.52 on it, and there's the MyCHIPs, which is 4520.
Okay, so we have this name holder and partner. Does that connect with stock and foil?
Not necessarily, because in this case the holder is holding the foil.
Okay.
So the holder just means that on our database, our guy is holding the foil.
Okay.
And the partner would then be holding the opposite, whatever that may be. Now, because this is a foreign tally, we're only seeing one instance of this tally, or this UUID. If we look at the next two lines, you can see that they share the same UUID. And so if we look at John Shields and Ray Freitas, well, here's John and here's Ray. And so we're looking at this tally that they share in common. So in our database, we have the stock, which is held by John, and we have the foil, which is held by Ray. And then you can kind of see that the partners are opposite. And the number of chips or MyCHIPs on there is the same.
So they're kind of holding two ends of the same stick, right?
Correct.
But it does seem odd to me that we have two records for the same tally, right? Can you tell me about your reasoning why we have it doubled up like this?
Well, the database really just represents a user and stores the data relative or relational to that user. And we have two users on our database, and the stock is one record and the foil is another record. And we have to store those as two separate and distinct records because they really are. The relational database is not modeling tallies, it's modeling users. And each user holds a different half of the tally. And so we store that as though we don't know whether this is a local tally or a foreign tally. And we store all the data in that way.
But then why does the second one from the top is the holder's John Shields, and the second one from the bottom is John Shields, right? Like if you say, so each row isn't necessarily one user, it's
in this case, that's true, because we're not looking at the user table, we're looking at the tallies table. And so there's a many-to-one relationship here. So there are many tallies to one user, and we're looking at the tallies table. So we're going to see John Shields multiple times.
So one thing that is on my mind here is, because we have a stock record and a foil record separate in our database, we're going to make sure they have to stay synchronized, that one is the negative of the other, like in that partner net, the 2178 there, those numbers have to match, right? Or sum to zero.
That's the whole effort of the CHIT consensus algorithm. And we want to stay synchronized whether it's a foreign tally or a local tally. And so rather than using a forced synchronization at the database level, what we're doing is we're saying, look, we have John, and we have Ray, and the only way we're going to synchronize is in a distributed network. And so the chip consensus algorithm actually goes out as though it's going to talk over noise protocol to another node. It suddenly recognizes that these two users exist on the same agent, and then it just turns the traffic around and sends it back to the other guy's agent. But the protocol acts as though it's a distributed tally all the way until it gets up to the wire, and then it says, okay, I don't have to send this out over the network. I can process it locally. But the consensus protocol still is in operation, is still running, even with local.
By storing
partners.
these two separate records, it prevents you from having to have any special casing where, oh, because it was a local tally, we only have one record and we have to invert this one to get Ray's side, right? So we have John Shields and Ray, right?
Yes.
So John's side is stored. We could have just left that as our only record and kind of logically inverted it for Ray, but that's going to maybe be error prone. So just storing it twice requires more data, but also allows you to reuse.
Correct. Yeah. So we're just thinking as though everybody's a foreign partner in terms of data storage. We're not making any assumptions about where the other partner is.
So what would be the primary key of this table then?
This particular table is the primary key is the entity ID. So it's Ray's ID as a user on the system, and then a small integer indicating which tally. So you brought up John Shields. This is the third tally of John Shields, and this is the second tally of John Shields.
Okay. Yeah, and right in the middle there, I see the first.
Yeah.
Okay.
So
entity
for
sequence.
example, we can rerun this query, and let me order by 1:2. And now we're going to see all of Matthew's tallies
All in a row.
all in a row, but it's a little hard to see who they match up with. And so here's all of John Shields' tallies and the people that he's connected to.
Okay. So this one is more user-centric, this sort of view of this sort. That if I'm a user, I can look at this and see all of my tallies.
Yeah.
And the last one is connection-centric. So using that sort, you can see where two are connected because two connected tallies are going to be right next to each other because they share a UUID.
Yeah, you're talking about the different ordering that we just did.
Yeah.
Yeah, with this ordering, if I sort by the UUID, then they just end up adjacent to each other, which is handy.
Yeah. And you can see, if you see two UUIDs in a row, you know that it's a local because we have a record of both the stock and the foil on our server.
Yeah.
But if it's not two in a row, then we say, oh, that must be foreign because we hold either the stock or the foil and some foreign entities.
Yeah, there's another clue in the database which I'm not actually displaying in this particular query, but it's called part_ENT, and it will display this entity ID of the partner if it's a local partner. So the database is aware of whether the partner is local or remote, and we can use that in various ways. Okay, so is everybody kind of understanding this
One more
level?
question.
Yeah, go ahead.
One more question. So the sequence number, is that significant in any way, or why wouldn't the primary key be the entity and like the tally UUID?
Because, well, it could be. It could be. That would be an alternate way to do it. I think this is a little more efficient for what I'm doing because the tally UUID is quite large, and this gives me some way to do row locking. Just the mechanism.
It's also easy to predict what the next key will be too. The UUID is just random, but
Yeah. So that is just an implementation detail, but from a data normalization standpoint, your approach is just as valid. Okay?
Okay.
All right. Now, what we're working up to is a way to evaluate lift quality. And so I'm going to just bring up one more graph here. If you'll just bear with me for 1 second. So I'm in the protocol document in the repository, and I'm going to pull up the section on distributed lifts. And there's this interesting graph right here, which shows 3 different sites and how a lift can occur through a string of users. And what we're trying to find is we're trying to find segments within a single site of users that are lined up linearly where we can participate in external lifts or frankly internal lifts. We'll look at that too. But in terms of distributed lifts, we need to find a segment with a foreign user up here and a foreign user down here, which hopefully has some kind of external pathway where we can do a circular or a linear lift. So does this figure make sense with this is where we're going. This is what we're trying to achieve with these views. So I want to keep that in the back of your mind as we look at these data sets. So if we're site B,
If we're trying to achieve here, what we're working towards is, can we find a cycle of all these users that connect between internal on the sites or through external sites? Just find some cycle of connection.
correct. So in order to build up to that, if I'm site B, I need to be able to locate the segment effectively.
Okay.
Okay, so we're going to start by finding segments. Now, you can kind of see a segment here. I mean, a really simple one is Edward to Valine to Carolyn. That's a really simple segment that involves only one user, one local user and 2 foreign users. Here's a more complicated one that goes Joseph, Franklin, Valine, Carolyn. So that goes down here into 2 local users and then down to a foreign user. Now, we're making an assumption that a lift is going to travel uphill. So it's going to come in through Carolyn, go through Valine, through Franklin, and up through Joseph, or up through John, up through one of these pathways. Now, there's some more interesting ones here. There is Joseph to Ray, to John, to James, to Zoila. So that's a longer one. That involves 3 intermediate or local users. Does that make sense?
Yeah.
And
And there's another one that I'm seeing here. Like, you can go Zola on the far right to Carolyn to all the way over to Valine, right, through that foreign user Carolyn.
okay,
and up
so
through
I'm not seeing it. Is it this Zoila? Is that the one you're talking about?
Yep.
And
So we
go
go there,
up through Matthew and then Carolyn.
and then to the far left, Carolyn Bell on there.
So what that actually is that's 2 segments which coincidentally exist on the same agent. And that happens in the real world quite a lot. And so if we go back to our model, it would go through site B, and then it might go through site A, and then it might come back and go through a different segment through site B. And that's one of the really crazy things that happens in the lift world is that these lifts can zip around through the network, and they can actually traverse the same agent more than once. Could be many times. So we're not going to have knowledge of exactly how Carolyn, I mean, we can see it here, and that's nice, but we're going to need Site 3's participation. So we can't shortcut, we can't hotwire that circuit. We have to send it up through Carolyn to Site 3 and then hope that they propagate it back to us through this other site right here.
Right. But they may choose a different route to get to the same goal, right?
They could. So we send it to Carolyn, and then we don't really have a lot of control over where it goes from there, but it very well could come back through here to us.
But it's also possible through some other weird connection, it could come through Grendoline there, right?
It could
That
go.
Site 3 has other connections they want to make,
Yep.
and makes that
Yep.
wild.
Okay, now here, I think one of you asked about, is there a correlation between holder and stock and foil, holder and partner and stock and foil? and we said there's not. Now I'm going to tell you that there's not even a correlation between stock and blue and foil and red. And the reason is because regardless of whether you're holding the stock or foil, it's possible for you to send chips to the other person. So you can develop a credit balance or a debit balance on either half of the tally.
Okay. So
Now,
what is the benefit of differentiating between stock and foil?
it's purely a convention to differentiate the parties, and that's it.
So really is it just for consensus then?
It helps in consensus because we can decide who's going to control certain things about the consensus. And it also helps when we write the contract because we can say who are the parties and how do we identify them. So, like when you're writing a legal contract, you might say lessor and lessee, renter and landlord. You just give people names in the contract. And so stock and foil really comes down to an arbitrary name that we're giving to each of the parties so that we can tell them apart.
Okay. So that means that we shouldn't be looking at stock and foil in the implementation code at all, because that's going to lead us to errors.
Correct.
Where we thought that would be positive, but it's really negative.
Correct. And in my very first iteration, I built it on stocks and foils, and I had to come back and completely redo it based on tally balances. So what we're going to do is we're going to analyze this in terms of what the actual present balance is, and we're going to say that it's a segment up through this going uphill, but it could also be a segment going downhill. Just depending on what the balances are, we still need to structure our database to be able to look at this in the uphill direction or the downhill direction. And so we're going to build a graph that can show us connections in both directions. Now that's pretty easy to build right here because we have a stock and a foil. We have an instance of both of these units, and we can kind of look at one of them as the uphill path and look at the other one as the downhill path. But when we're looking at this one, we only have one instance. And so it's kind of hard. What we do is I create a view where I take each of these foreign tallies and I sort of invert them to make a mock copy of the other half of the tally so that I can create two instances in my view of this pathway. Now, I don't know if that's going to blow your mind or not. Feel free to ask.
That's exactly what I was talking about, why are we storing both stock and foil when we can invert them and mock it and figure it out? The data's all there, it's just duplicated.
Yeah. Well, in this case, we need to duplicate data in order to create this next view.
Right.
I'm going to look at the reports and just show you. We started off with this tally report, and now we're going to go to this edges report. We're going to kind of skip over chits since that's not material to our analysis right now. But we're going to go next to the edges query. And
before we get too far off, something that's kind of on my mind is if the stock and foil is just for contract identification only, is it possible to remove that from the implementation, like remove that from our documentation so that it just adds a level of detail that might not be necessary for someone that's jumping in new to MyCHIPs to see? Might be nice to.
Well, I've thought about that. I guess the question is, if you and I were signing a lease, would you be okay if we arbitrarily decided who was landlord and who was tenant? And
well, I guess if it's just for identifying parties, we can identify each other by name, right? We all have names. So rather than having a stock and a foil, it's just Kyle Bateman and Kyle Story, right?
Yeah. I guess the answer to your question is there might be a way to do that. I just got done doing the contract implementation, and it was very handy to have the stock and foil monikers because of the way the contract is written. But yeah, what you're suggesting is tempting, and I'm open to it. It's pretty deeply embedded right now, so that might be a project. But yeah, there could be another way conceptually to do it besides that. What I guess I've decided so far is I've decided that most tally relationships, most formal tally relationships, are going to have a vendor-client relationship. And so we could adopt that nomenclature instead. But in most cases, somebody's going to be buying the stuff and somebody's going to be selling the stuff. And it's really only in the really casual relationships, like a lunch group, where it's going to be arbitrary. Even if you're paying the local kid to take out your garbage cans every week, that's an informal relationship, but there's still a vendor-client relationship.
Right.
And I don't know. So that's how I've gotten to where I am. Okay, so let's run this next query, and this is the one we're doing. We're running our report script on the edge query, and I'm going to order by UUID since I know in advance that that's what I want to do. So now we have the same situation where we're showing UUIDs of the tallies, but we're going to see that in every single case, the UUID is going to appear twice. And the reason is because I'm making sure that that's happening. Where it's an internal tally, I'm querying the two different halves of the tally. Where it's an external tally, I'm making sure that it appears twice. Once in the forward direction and once in the reverse direction, so that I can create every possible edge in every possible direction.
So as I understand, right, you're generating their side of the tally based on what you know of your side. You're generating what you assume they're holding.
Yes, and there are certain things that we know about them, and so we can manufacture a reasonable representation of the other half of the tally. And we can even know what their trading variables are, and so we can gauge that as well. So there's quite a lot we can know about the other side of the tally, even though it's hosted on another site. So now instead of looking at tallies V, we're looking at tallies V net. And this is just a preliminary layer view of the data that we're going to build on top of with our next view that we're going to see. And just to look at the views, we have the tally that it belongs to and the tally sequence. So we know what tally we're looking at. We know the tally type. And then we know whether we're looking at a drop or a lift. So drop is just kind of think of it as a negative lift. Normally lifts would flow from stock to foil, but if the balance is backwards on the tally, we're going to flow in the opposite direction. And so if we're going to look at this edge in the opposite direction, we're going to be looking at it with this record. If we're looking at it in the normal conventional direction, we're going to be looking at it in this direction. Okay, you with me so far? So now we have 40 rows, so there should be 20 tallies on here. I don't know if we want to spot check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 18, 19, 20. Okay, so I count 20 tallies visible on here, and so we have 40 rows, and we're looking at every edge in every possible direction. Okay, any questions about that one?
Cool. So as I understand, we're building this table so that we have all the data we need to look for cycles all in one place.
Correct.
Okay.
So now what we're going to do is we're going to line them up in end to end, because we kind of know who the input is, and I'm not displaying it. I'm not displaying the input CIDs here. If the input is local, I have a node here. If it's a foreign node, it's null, and we would have to look somewhere else, which I'm not currently displaying in this query. I could probably add that. So if you see one of these tallies, if you see one of these canned queries that you're interested in, just copy it and paste it, and then you can come back and let's try adding input CID and just see if that's in here. And it looks
Of course,
like,
that's easy enough for you because you know what these
well,
columns might be called.
I
but
just
we would have to
demonstrated
keep
that
it
I just demonstrated that I don't. So what you can do, there's an online data dictionary which I'll show you right here in the admin interface, and you might jump on here and look for that MyCHIPs view that we're looking at. It's called tallies v net, and you might just open that up and look at some of the columns that exist in there and find out what there is to see about that view. Okay, so that might be one way. It looks like I hit my back button. That might be one way to figure out some of the, you can also look at the source code, but you can modify these queries is the point. So now let's look at local paths. So that's going to be the next query, and let's do that one. And I'm not going to order that one, so let's just run it as it stands. Now, I again have some selected queries here, but what we've done is we've lined up little pathways. Why don't we order by the edges? So this is going to kind of make sure that the longest pathways are at the end of the query, and the shortest pathways are at the beginning of the query. So we have from Geraldine to Valine to Carolyn. So let's see if we can find that. Where's Valine? Right here. So we're looking at from Geraldine, forgot who that last link was, to Carolyn.
Valine. Yeah. Geraldine to Verline to Carolyn, which does appear to go up. It's a lift one way and a drop the other way.
Okay, so it's going through here.
Right?
Going through here. And that is a possible pathway, but it could be quickly ruled out based on the balances, but it is one of the many possible pathways that could exist.
If there's various targets, right? Maybe Carolyn wants to build up a credit with Valine. They want to buy something big in the future, so maybe Carolyn's target is -10, and there is a lift that's possible there.
So here's one of the longest ones, is it goes from Joseph to Chad. And let's just see if we can see where that is. So it goes
next?
Joseph to Ray. So it goes Joseph by way of Ray and terminates with Chad by way of James.
Okay.
So where's Ray? So here's Ray. So we've got a Joseph connected to, so there it is. Joseph connected to Ray, which goes to John, which goes to James, which goes back to Chad. Right here. So
cool.
it's pretty confusing to look at on the visual graph, but these views will help us by providing every possible permutation, and then we can start to narrow those down via SQL and kind of decide which ones we're looking at that we think are interesting.
So can you tell me a little bit more about this null P1003 ending with null? What does that mean?
So this is a pathway of users, and the signature right here is how I know that this is a valid segment, because it contains all internal nodes and it has external nodes on the ends.
Okay, so if it comes back null, that means it's an external node, right?
At least in that column. I mean, this is just a thing called path, which is a PostScript or a Postgres array that shows me the nodes along the way. And if for any reason that's handy for me to consult, I can consult it. I included it here in this query just because it's visually helpful, to kind of see where we're going.
Okay, so if, for instance, there was a foreign user in the middle, right, like we're going through twice, we would expect to see null, some p something, null, p something, null. We'd have a null somewhere in the middle, representing the foreign entity somewhere through the middle of the path.
Correct. And
Okay.
because of the way I'm doing this, where segment rules those out.
Got it, okay.
Segment, by definition, in this view, is something that looks like the signature. It has foreign users on the ends, and it has local users in the middle.
Got it. Cool.
And it turns out that if we link on Carolyn, like you were looking at, those turn out to be not very helpful to us in the algorithm, so I just kind of rule those out. They're interesting, but I can't enforce anything on them. I can't use them for anything very useful, so I just kind of ignore them for most purposes. Okay.
Maybe
Yeah.
this is a conversation that'll come up later, but is there a way to connect, because these foreign users might have a deep connection between Carolyn and Carolyn or someone, maybe
Geraldine.
Ziola, right?
Yeah.
I can't say that name, but Carolyn and Ziola, right?
Yeah.
There might be some connection there they could make.
Yeah.
Is there a way that there's like a rumor protocol you've talked a little bit about? Is that something we'll talk about here? Or
Yeah,
something?
we're going to be
Maybe-
seeing that in just a minute.
Okay, sounds good.
So we also have a thing called circuit. And with this limited data set, there are no records that perform a circuit. But if there was a circle, we would be able to do local lifts.
So is F for fail, or what does F stand for in circuit?
False.
False. Okay. So it's a true or false Boolean value.
Yeah, now if I just do all here instead of 0, we're going to query all of our nodes instead of just the 0, 1. And let's just kind of glance down and see if any of these are true. I kind of doubt it. But let me just spot check and see if our data set produced any trues. And I think the answer is no in this case. So one of the ways we could do that is we could, I'm going to copy the query, and I'm going to come back and say where circuit. Let's try this. That's a better way to do it.
For that, rather than manually.
And we can kind of see, I guess, order by, let's see, I didn't want that in there. Or circuit. And we have 0 circuits in the current data set. Now, if we made a rich enough data set here, we would pick up some circuits. If we let the simulator run long enough, we would pick up some circuits. But at the moment, none of these nodes have the ability to do local lifts because everything is linear on all 4 of our pathways.
Would it be possible for us to insert a manual tally and try it? See? How hard would
You know, when we get done with this view analysis, let's go back and rerun the simulator and let's see if we can generate a rich enough data set to do that.
Sure.
Because it does happen. I think the number of users that I have and the number of iterations, it just turned out that way on this data set. So now I'm going to go to routes. And routes are a totally different data set. What we were looking at last time was paths, which is based on our local actual tallies. And now we're going to look at routes. And routes are based on the rumor protocol that you mentioned. And what happens in the simulator is every time we create a tally, or anytime we receive a chit, we send out a question. We probe our adjacent partners and we say, hey, gee, do you have any external pathways that would allow me to do certain interesting things? So let's go back to 0 and let's say we have this Valine, this pathway through Carolyn to Valine to Edward. Well, it would be really nice if a pathway existed in the outside world that would connect Edward back to Carolyn or back to Geraldine.
And then this one user can just perform lifts through that cycle, right?
So in this case, A3 is our foreign user and C1 is our foreign user. So we're saying, gee, outside world, hey, site A, is there any chance you know a path to C1? And we send that query up here, and that query can propagate through the cloud, and if it ever makes it back to here, it's going to come back to us and say, absolutely, site B, site A do think I have a pathway to C1, and so if you ever need a lift, feel free to reach me, and we'll give that a shot. And so we're looking at now a query of that pathway data, and there's a routes V table, and this is a cache table. We just cache that information in here, and it has a status. Now let's grab that query, and let's manually run that query again, and let's modify it a little bit. I'm going to get rid of this where status thing, and we're just going to run it on everything. Now you're going to see we have some drafts, we have some goods, we have some pendings, and we have some nones. So we can get various answers back from adjacent nodes. If it's pending, it just means we've asked and we've never heard back. I'd have to look at the rules to see the difference between draft and pending. Can't remember that for sure. Good means I've definitely got an affirmative answer. None means I've gotten a definite answer that will never work. It cannot work along this pathway, and so that's kind of one I don't really need to look at. Although
I imagine things change a lot as new tallies are created. So
correct.
Maybe that none, you send it back anyway occasionally, right?
Correct. Each one of these has an expiration date on it, and they're probably all expired because I ran this data set, a couple of days ago. Whoops, I want expired. And we can see that these routes are all expired, but there they are. And so anything that's good is interesting, and we should probably be paying some attention to. Okay? So that's the next level.
Protocol. How does it, in concept, it makes sense. You ask your neighbor, and they're going to tell you good, bad, like good, none, whatever, right? But how do they find out?
Well, they ask their adjacent neighbors.
Okay.
So they look first.
Like it principally goes until we ask a neighbor that does have a direct connection in their database saying, oh yes, I know B3.
Yeah, if this query, if this rumor ever hits site C, it would know about C1 and B3. And I don't remember which of those are targeted. It's probably C1, but site D might have information. The other thing is they can consult their local cache. They might just have a cached record already, and they don't even have to propagate the rumor. That algorithm is fairly simple-minded, but it does seem to produce results in the simulated data set.
Yeah, so I'm imagining that site B sends this to all its sites that it knows. Site A, whatever, like D, E, F, all the sites it knows. Site A is going to send it to all the sites it knows, right? And it feels like there's exponential growth on this rumor.
Yep.
How do we cull that? How do we prevent infinite?
So we maintain a step value, which tells how many steps it's gone. The other thing is that site B is not going to send it to everyone it knows. It's only going to send it to sites that have this A3 connection.
Right, okay.
And so it's going to
everyone that's connected to B1, its target. Right?
That has a conceivable path, yeah. So we take this input path, and it's going to fan out, but it's not going to fan out crazy. It's not going to fan out across our entire data set. It's only going to fan out according to the tallies that A3, A2, and A1 have.
Right.
And so...
of course, that's one possible segment, but if A3 has 4 possible segments, now suddenly there's more possibilities, right?
Yeah, so if there are lots of tallies that A3 has, then we're going to have lots of other places it could go, and that could fan out to multiple sites. So if the step value is only 2, we probably want to propagate it to all of those. If the step value is 20, we probably want to prune that and just say, you know what, I'm not going to propagate that. And the policy is up to each node, up to each site to decide what they want to do. They can propagate or they can prune, and it's really up to them.
There's a motivation problem here because each site is motivated to send it to as many as they can,
Yeah.
but they don't want to receive that many.
Yeah.
So they're going to have to respond no, or I don't know. That's just something to think about, is that could explode. It'd
Well,
be very
I think what it
expensive.
will do is it will either bog down the network or it will fill up the cache. And I think in either of those cases, sites will be incented to prune.
Right.
And so I don't know how, other than empirically, I don't know how to decide what step level is too big and when we should be pruning.
Right.
That's where the simulator would be really helpful to answer that question.
It's tricky.
Okay, so let me see if I can remember what these fields mean. I'm a little rusty on this, but what we're saying is that site 0 is looking for a destination of Zoila, and that's likely because we see Zoila down here on the bottom in a couple of places. So we're saying, can you find us Zoila by way of Matthew? So here's
Is
Zoila.
Matthew foreign or Matthew's local, right?
Matthew's local, so we're likely looking at this link
Right.
through Carolyn Bell. And so what we're querying is this little segment right here. So
Nice.
this is telling us that there is a feasible external pathway through that link. So we could theoretically do a distributed lift right through here. Okay? So the data set said yes on that one.
Cool.
So let's look now at external pathways. This is gonna query this this view, MyCHIPs routes v paths. So what we're going to do is we're going to join our internal data with our cache data and try to hypothesize about external circuits. And so let's do report, and let's do X path, and let's just see what we get. And now in the circuit category, we're getting some trues and some falses. So this data set is set up where we could do some lifts. It's beyond the scope of this presentation, but there is a stored procedure. And when we get, I don't know, maybe we'll do it at the end if we want to, is
Sure.
we'll actually try to propagate a lift. The reason I say it's beyond the scope is because I don't remember it well enough. I'm going to stumble all over myself trying to do it. But there is a stored procedure where we can say, please try initiating a lift through this pathway. Now, it does not use a referee. It kind of uses the old version 0 lift protocol. It's using as much of the protocol as it can, other than it doesn't use the referee. Let's put it that way. But we have some viable distributed lifts here. And so if we did, let's copy and paste this, and let's say where status is good and circuit. Let's just see how many we get. So I have 10 possible distributed lifts I could do right now with this data set.
Cool. And that's really interesting because we have no local lifts we can do. Those circuits were not found, but the distributed lifts work. So that feels like a likely possibility in a lift system, right?
Yeah, we could definitely, and I've done lifts. We definitely could do lifts. Let's just take a chance because I think I'm kind of at the end here. Let me just see if I can see that stored procedure really quick. If we can't, we'll do it later because I don't want to drag this video out. Attempt a
People might have to
circular
update it
distributed
next speed.
lift along the specified segment. It looks to me like that is not ready for prime time. So I'm not going to do it right now, but that's the stored procedure that needs to be tested and validated. And I can tell by looking at it that it's not currently ready to use. So questions about this? Sounds like none.
Well, I've just not been holding my questions in, right? I've been
Good.
asking as they came up.
Good. So the next thing I was going to go on to is I was going to show you how to use the simulator from scratch. And it's going to necessitating killing this data set. So that's why I wanted to see if there were any other questions before I go on. It sounds like there's not. So what we're going to do is we're going to wipe out that data set. I'm in the README files in the section about Docker simulations, and I'm just going to refer to this so we can kind of see what's happening. I've already run this, so I'm going to do a step to shut this down, which you won't normally do when you're starting from scratch. So normally we would do these two steps. I think this step is probably not needed anymore. I should probably go in. I'm not doing it, so I think we probably don't need that. I can go in and update the docs to that effect. If we want to look at debugging, we need to have that done, and then we're going to run this startup command in SimDoc. Now before I do that, I'm just going to run docker ps, and I'm going to show you that there are no Docker containers running on my system. I'm running this native on Mac OS. That's a little bit confusing to folks because the server only runs on Linux. So when we're in the simulation environment, I've been running it on Mac OS. It should run on Linux, but I haven't done a lot of testing on that. It's possible that it could run on Windows if you have access to Bash. And I think there's a Git shell, I don't remember what it's called, that comes with GitHub that provides kind of a Unix compatibility layer. I'm fairly hopeful that that could run under Windows.
You could also consider Windows Subsystem for Linux. That's a Windows feature. It allows you to
Correct.
run Linux.
But because this is a Docker-based installation and it's running in Bash scripts, I'm thinking that it could run native Windows if you have the right environment for it that has full access to Bash. So what we're going to do is we're going to export, and we're going to start up. Now, this is going to create a bunch of shell windows, which is all fine and dandy for a small simulation. For a larger simulation, it's going to be a problem. So if we do Docker simulations in the cloud, we've got to figure out a way to monitor these different instances in a better way than what I'm doing. And I'm not quite sure what that is yet. I'm going to do one other thing before I start, is there's a thing called config.doc, which is the configuration for this simulator. And it does things like how many users are we going to run and how many sites are we going to run. And there's also a local version of that which you can build. You'll have to build the local directory, you'll have to make it and copy stuff in there and then create your own little custom version of this. So I have, I guess that's commented out. So we're still at 4 sites, but we have 6 users. And so that's going to start us up. So I'm going to do SimDoc startup, and it's going to create some Docker containers. And you can see that it's building some shell windows up here with the debugging or the console running for each of these containers. Now if I look at my Docker, I can see that I have a bunch of Docker shells running. I have Postgres running, so I have 4 instances of Postgres, and I have 4 instances of kind of a fractional version of the server. The MyCHIPs server is really multiple servers in one, and we're only running the piece of the server that the UIs connect to. We're not running the peer-to-peer portions. We're running what the UIs connect to. And so my UIs are right here, and if I double click on my connection key, or if it times out, it'll automatically reconnect and reconnect these UIs back to these servers. So the UIs are connecting to what's running in these windows. Now, what's running in these windows is the Postgres. Does that make some sense?
Yes, I think so.
And we can see the Postgres is up and running.
You mentioned we're not running the peer-to-peer. Is that going to prevent us from doing distributed lifts?
Well, that's going to happen in a minute when we run the simulator.
Got it, okay.
But when I do startup, when I do SimDoc startup, which is what we just ran, all it's going to do is it's going to launch Postgres instance for each site, and it's going to launch the UI. Now, if I didn't have it's the UI server. If I didn't have my UI clients, which I don't right now, then we would do the next step in the procedure, which is to run this tickets. Let's see, where is it in the help? Okay, so to run this SimDoc tickets. And you can do them one at a time, or you can do them all at once. So let's run SimDoc tickets, and let's see if that'll launch my Chrome. And you have to kind of tell it whether you're running Chrome or Firefox in your startup, in your configuration folder. And so what it's doing is it's reaching out to each of those servers, it's generating a connection key as admin, and then it's launching a browser window on the data set so I can see what I'm doing. So I can kind of peer into that. And by the way, here's a database browser. I don't know if looks like in my simulation environment, I don't have my schemas built yet for that. So it looks like that's not working yet. But if you start from scratch, I think there's a relatively good chance that will work, and you'll be able to browse the database in that window. Let's do user check all. So SimDoc user check all. It's going to check all of those databases and make sure that we have 6 users. And then I'm going to do something that is not listed yet in the help, because we're dealing with an old. I guess it did initialize that. So never mind. It looks like it initialized our user. Let's get back to network. It initialized our user database, and it deleted all the tallies and chits in the system. There is a SimDoc init which we could run, which kind of does the same thing. But it looks like that user check did that for us also. And now let's run a simulator run. So we're going to start the simulator. So we're going to do start sim, and let's do runs. Let's just do maybe 20 runs of the simulator for starters. And
so what is a run in this case?
Well, it's just an iteration of the agent model, of the agent-based model. And it's going to run through its loop 20 times.
Could we peek at that loop? That might be nice to
Yeah,
see.
but let me show you first what's happening. So we're going to watch in real time as the simulator is running. And right now, it's going out and it's looking at the users that exist in the database. It's acting as them. It's launching this little agent that's supposed to act like a user. And that user says, gee, I wonder who else exists in the world. It queries a database not a Postgres database. It queries a Mongo database and says who exists in the universe. It finds someone, it meets them, and it says, hey, would you like to tally? And currently, the agent-based model always says yes, and those two forge a tally, and then they start paying. They start generating payments on the tallies. And so it's fairly simple-minded, but it works. And if you want to see it, it's in the lib folder. Agent 2 is the one that we're using. Let's see, what am I doing wrong here? Oh, Model 2, sorry. Model 2. And it's 309 lines of code, and it is fairly dense. I'm not super proud of it, but it works for its purpose. And if you want to see the logic is in there. There are some parameter settings in here. I don't remember. It looks like it's not currently populated. In the settings tab, we can add settings, and the simulator will accept them. Even while it's running, you can change the values. And if you update them in the database, it will alert the running agent, and it will change its behavior on the fly, and it will start making decisions according to the parameters that you've set in there.
Cool.
Okay, now we saw some additional windows show up. These windows are the agent-based model that's running, and we can kind of see debugging output coming out of there and telling us, so we're on run 19. Remember, we did 20, so we're on run 20, and it kind of tells us that it's acting on behalf of Franklin Goldstein, and it's generating a payment from Franklin to James Hardy, and that's what it did in its run. Then we have some windows over here. These are the peer servers, and this shows us all the traffic going back and forth in between nodes as a result of the tallies and chits that are being generated. So when we're debugging the protocol, this is where I go to try to see what's happening in the simulator and see, how these packets are propagating back and forth. And so we have 4 instances of the peer server, and we have 4 instances of the agent modeler running. And again, if we're going to run a mass simulation in the cloud, we need a better way to monitor this information rather than running externs on a computer. We need to have some method to reasonably monitor what's happening on those. And so now we have a fairly simple data set that we can see running here, and that's how that works. Now, if we go back to, I do need to stop the simulator, by the way. It is running, even though it's stopped iterating. These servers are still live. If we look in the Docker, we can see that we have peer servers also now. We have an instance of a Mongo database running, and
Can you tell me more about that Mongo database? They are looking for peers in there, you mentioned, but how does that get populated? What's in it?
well, it's purely a function of this simulator, and it basically we query all the instances of the Postgres database. We find all of our users across all of our agents, and we populate the Mongo database with all of that stuff so that a user on agent 0 can find a user on agent 3.
Okay.
Otherwise,
so rather than having to query each other in like some distributed thing, it just makes it so that there's an easy place to find data for simulation only, right?
It represents the out of band channel. It represents not MyCHIPs. It represents the real world.
On the street is the Mongo database.
Correct.
What we're simulating.
Yeah, and I did that for a couple of reasons. I wanted to learn Mongo, and it seemed like a good application for a document database, and it just seemed like the right tool to use. And so I went ahead and used Mongo, and it worked out okay. Mongo is not very good at asynchronous, and so I had to kind of kludge that part, but there is a way to make Mongo provide asynchronous notifications, and so it worked out.
Cool.
So let's just do a couple of experiments with that, and then you can ask questions, and if not, I think we'll be getting fairly close to the end here. So let's get into our local configuration, and let's change our users to 12. And I don't know, I'm not going to do the sites right now because I don't want to bog things down too much. But let's just change our users. Let's do simdoc init, or let's do user check again. And that's updating on its own, by the way. And then let's do a run of 30. And let's just watch that run and see what happens. Now this is going to be a little slower in some ways because every iteration of the agent is going to take on the persona of each of these people alternately. So with 12 users, it's really going to do each user, just a couple of times. Okay, now while that's running, I'll just give you a couple of other pointers. There is a folder up in test local. Let's see, that's not where it is. It's in local under sim. Let's just look there. Let's do a long listing. There's a directory structure for each one of these nodes that we've created. So this is DS0, 1, 2, 3. These are the worlds that, the file systems that exist for each of these sites that we're setting up. There are log files in here. I create scripts for myself when I'm doing tasks. Like when I'm setting up simulations, these are some custom things that I set up. So if we look at local r.barb lift, that was a lift that I was practicing on with somebody named Barbara. And I just will I'll automate a whole bunch of simulation steps and things kind of that I want to do. And I can do higher level tasks by chaining together lots of runs of the scripts. And I don't have those in the distribution. It might be nice for me to put some of these shell scripts somehow in the distribution, but none of my local folders get added to the distribution, but just to show you that. So if we now look at local DS0, you can see that there are log files in here. Let's see what else there is. There's PG data. So for example, if you've run the simulator and a new version of things has come out that has a brand new schema, you got a couple of choices. We could manually update the schemas on all of those instances of the database, or we could just come and wipe out. We could just delete. We could stop the simulator, delete this PG data folder, and next time we run the simulator, it'll kind of start over from scratch, and it'll rebuild those databases with the latest version of the schema. So that's something good to know. Okay, so our simulator has run, and it looks like we've got some data in each of our sites. And as we go back, this modeler will kind of try to, sometimes we have to stimulate it to refresh. You can also drag things a little bit. That makes it reheat the model and kind of try to rearrange things a little bit. So you can see it working away at that. This one's a little
It's
bit.
trying hard, but holy cow, it's
That
a
one's
mess.
trying very hard, but it's eventually going to kind of settle. Okay, I've reached substantially the end of what I wanted to show you on the simulator, so I'll entertain any questions, and if not, I'll probably turn off the recording and we can do anything else that you guys have on your
So
plate.
have we done a lift? Is that something we can try?
I checked, and no, I can't do that right now without me doing a little bit more work on the database, so maybe we can have that for a future session.
Okay.
If we could do a data set that was complex enough that could do local lifts, I can do the local lifts. But I looked at the function for the distributed lifts, and I think the answer is clearly no. It's not ready for prime time. I'll do some offline testing on that, and if I can get that ready to go, then I'll reconvene one of these and show you how that works.
Sounds good.
So I guess one of the questions for you, KS, is based on what you were trying to do to visualize data sets on your own, do you see a way that you could use this to accomplish that same exploration?
Yeah, so I guess one question I had is it seems like your simulator just randomly connects users. It's just completely random, which gives you a vague idea, like it's pretty hard to know how people are going to connect in an economy, right?
Yeah.
And it gives you a vague idea of how lifts are going to be possible and how well this might function. But I'm wondering if we can adjust the model so that we have different types of users. We have employers that tend to have a lot of people pay them, consumers, and pay a few employees, right? And we have
Correct.
consumers that tend to be paid by one person and pay a lot of people.
All right.
And create these different types of users and mix those and try different mix ratios and see what creates a healthy MyCHIPs ecosystem.
Well, this is something I'd really like to explore. And Bill, who just came on recently, is also someone who might be exploring in this area. So you guys might collaborate on this if this is an area you're interested in. Let me just tell you the three modelers. Model 1 works exclusively on a single site, and it's just what I wrote in the very beginning to create example data for single site tallies and chits. And I still use that to this day. I've run that modeler on mychips.net recently in order to create some data so that we had something to look at. Model 2 is what we're running right now, and it generated this data set. If you look in our local config.com doc, you'll see that the mod version I have set to 2 right here. It's also possible to set that to 3 and run this version 3 modeler, and this is what the BYU Capstone team wrote, and it's written in TypeScript, and this is kind of the main loop for it, and then there's some support modules under here. So if we go into Model 3, you'll see they have account factory, they have different kinds of accounts, they have document folder for what they did. They have their Mongo World Manager. It's written to kind of work the same way Model 2 works, except you're supposed to be able to create profiles for different kinds of users. For example, in accounts, they have a base account, which is an inheritance class, and then they have employees and retailers. So
Cool.
that's all they started out with, but you should be able to make an employer, and you should be able to make a bank, and all kinds of different agents, and make them behave according to different logic rules.
Cool.
And then there's supposed to be
Yeah.
some randomization in there so that 2 employees are not the same as each other. They're going to act
Right.
differently.
Yeah, so it seems like they've built the structure, the bones of what they need, but it's not quite as fleshed out as you hoped it was. Because you mentioned that it does just about as good as Model 2, which is
Correct.
unfortunate because there's a lot more code, right?
Correct. So I think they created a framework. I won't say it's a fabulous framework, but I think it would appeal to people who like TypeScript because it's using TypeScript. and it's got lots of code and types and classes and inheritance, and I think it helped them with exercising some of the principles they'd learned in their classes. I'm not really thrilled with some of the structures, some of the singleton structures and ways that they've done things. I won't say I'm overly thrilled with, but I think it's a good start, and I think it would be really nice if we're going to make a fully functioning agent-based model. I'd prefer not to make agent 4 or agent 5. I'd prefer to just come back and work off this code base and fix it and clean it up and make it into the neat new thing. Now, I think if we did that, we could answer some of the questions, like how do we prune route queries, and what's the average distance of separation between me and any other arbitrary node in the network.
Right. Say it's 7, right? For any 2 humans on Earth,
yeah.
It takes connections to.
And that's somebody I think it's going to be a bigger number for somebody you're willing to tally with.
Right. Yeah.
But if we had a few market makers that became very popular and had big sites, then that could bring it back down again.
Yeah, because I think the real question we're trying to answer is, what is it going to take to bootstrap this? Because MyCHIPs is not going to be valuable with nobody on it.
Yeah.
It's only going to be valuable once it's reached critical mass, and getting between those 2 states is tricky, because if it's not valuable, people aren't going to go on.
Well, I think you're right. I have some alternate opinions about bootstrapping. Is that I think if we get one sort of low-key barter site or classified ads site, it's kind of like an off-market version of Craigslist or KSL Classifieds or something like that, where people can buy and sell, and you find kind of an informal group. I think that's going to be one of the ways we can bootstrap. I've also got some alternate methods we can bootstrap to create kind of a artificial community of tallies and value and transactions. And then I think once you get that little bootstrap, I think you can start building on the periphery of it. And
I'm working on a system that could use this as well. So
very cool. It sounds
Okay.
like